So let me start with the introduction. So I am Amir Siddiqui. I work as a data scientist with T-Systems and I am from India. I have over 10 years of experience in data science and analytics. So I have already shared the material in the chat. You can find it. So today's topic is object detection using OpenCV. And in this tutorial, we will be learning about computer vision, OpenCV, and object detection in particular. And before I start the tutorial, I would like to give you more information about the work that I do and also about my YouTube channel. And I can also share my LinkedIn where we all can connect. So I'm also associated with this platform Tech Women. So this is especially for women who wants to get a job in a tech company and they can register here. So this is in the beginning phase. And if you would like to register yourself here, you can click on this QR code and you will be landed on that page. You can register yourself and you can find opportunities to work in tech. And this will be mostly about the remote job. Then I have a YouTube channel, StatsFire, where I upload tutorials about data science, AI, and ML. And I have a complete series on OpenCV. So if you want to learn more about the OpenCV, you can subscribe to my YouTube channel. You can go here. This is the logo. And this is my LinkedIn account. We can connect on LinkedIn and you can ask me any questions. So now let's talk about the agenda of this tutorial. So we will learn about what is computer vision, object detection, OpenCV, and what are the steps involved in object detection, and not just the one method, but what are the different methods that can be used for object detection. We will learn about them and we will implement one of those algorithms. And for that, we will go to the Jupyter notebook and we will see the code in implementation for one of the algorithm that will be used for object detection. So first of all, we need to understand what is computer vision. So computer vision is because we are talking about images and video. So what it does, it is a branch of AI and it will enable machines to understand the visual information. So visual information includes your images, your videos. So whenever you are working on these data set, you will be using computer vision. And in computer vision, there are different applications. So one of them being image recognition. So in that, what you do is you have, for example, 2 or 3 images, and you want to recognize whether the image is of a man or is of a woman. In case of animals, you have like cat or dog. So you would like to recognize whether it is a cat or it is a dog. So that is part of image recognition. Then we have object detection that we are going to see in this tutorial. So in object detection, we don't classify any images into their categories, but we try to identify all the objects within that image. So whatever number of objects we have, we will try to find out those objects in the image. Then we have image segmentation. So here we divide the image into different segments, and then we try to identify a particular image in that segment. So we do not work on the image as a whole, but rather first we will segment all the images. We will make some groups, and inside that group, we will try to find some classes of image or some particular objects in that image. Then the next application is face recognition, where what we do is we train our model with our own faces. So for example, you have a team in your office, you will train a model with all the employees working in that team, and then you can implement that model as an attendance for your team. So for example, you are coming to the office and the model will detect that you are an employee of this, and that model will mark your attendance as present. So that is face recognition. So that is one of the implementation, but there are various other implementation of face recognition as well. And then we have gesture recognition. So in this, what we do is we just let's say we wave in the video, or we say hi, or we just show our fingers 1, 2, 3, and then it will count and it will detect that we are saying hi, or we are saying bye, or we are showing our fingers. So that is part of gesture recognition. Then we have OCR, and OCR is for optimal optical character recognition. So what we see in our check or in our identity card, our government ID card. So we have objects, our name written there. So we can extract those objects from those ID card, and that comes under OCR, or the optical character recognition. Then we have scene understanding, and here we do not try to find a particular person or object, but we try to understand the overall context of a scene. So we will take the whole scene as a overall, and we will try to understand what the scene is, whether it is from a forest or hills or mountains, beaches, so like that. So these are the applications of computer vision. And as I said, computer vision is nothing but whenever you want to work with image or video, you have to use computer vision. Then now let's start with the object detection, which is the main goal of our tutorial. So what do you mean by object detection? And here in this picture, you will see that there are three images. So we have two images of cat. So these are the two images of cat. And then we have here dog and cats as well. And we also have a image of duck here, which is small in color. So as I said that there are different applications of computer vision, and one of them is object detection. So if you look on this cat on the left hand side, these two cats, so what we are trying to detect here is whether this animal is a cat or not. So this is a classification problem. So we are just identifying whether this animal is cat or any other animal. So this is classification. Then on the right hand side, you will see that we have a picture of cat, as well as you will see one red color square here. So this is known as bounding box in computer vision. So the difference between your left hand side picture and this picture is that in this picture we are just focusing on the cat, and that is done with the help of this red square here, and this square is known as bounding box. And this is very important concept in computer vision. So on the left hand side we are taking this picture as a overall. So we have this grasses in the background and everything you can see in this image. We are taking everything, and based on that we are doing the classification. But here we are not doing that. Here we are first creating a bounding box to detect this is a cat, and then we are classifying that this is a cat. So here there are two steps involved. The first step is to create a bounding box which is of red color, and the second one is of classification. And now third comes the object detection that we are seeing here. So the difference between this classification and classification flow plus localization is that in this image, you will see that we have different categories of animals. We don't have just cat here. We also have dog, and we also have an image of a duck. So we have all kind of animals here. Now our goal is not to classify whether this is a dog, or this is a cat, or this is a duck, but we have to identify each and every object in this image, and that is known as object detection. So here we are identifying this is as dog, this is as cat, and this one is duck. And here also, so since here we are having two cats, so we have these two bounding boxes here. So first one you will see on the left hand side, the second on the right hand side, and the third one is the dog, and fourth one is the duck. So this is the overall difference between different image classification or image algorithm you will see, and they all are different. You might find it same or similar, but these are the basic difference that in one of them you will do classification, in the other one you will do classification plus localization, and in the other one you will do the object identifying all the objects in a particular image. So this is object detection. Now let's see what are the importance of this object detection. Why do we need this algorithm, and where do we implement it if it is really good and if it is really helpful? So the first one is the implementation of first is image and video analysis. So for example, you have an image, and in that image you have some persons, you have let's say you have some trees and cars, and let's say you have some different objects here. So you can find all the objects in that image, and it is not just restricted to image, but you can do the same in a video. So if you have a video and you want to identify a person moving in the video, then you can apply the same algorithm in your video as well. So there will be very minor changes, but overall it will remain same, and this you can apply in both image and video. Now the second one is autonomous vehicles. Now you must have heard about that now we have autonomous vehicles where we can drive this car without drivers, and you must have also heard about the vehicles from Tesla that they are driverless. You don't need a driver to drive these cars. So how does these cars work? Because now if a car is going on the road without a driver, then there is a high chance that the car might meet with an accident. So how would you train a car that a car can go on a road and drive smoothly? There is no accident. So here we use this object detection. So what we do, we train our model and we recognize all the objects that you can find on the street, whether it is a person, a signal, different cars, motorbikes, cycles, and everything that you can find on the street. You will train your model with all those objects. So once this car start running on the road, it will identify, okay, this is an object, let's not go there. Then it will find that, okay, this is another car, so I have to stay away from this car, otherwise this car will meet with an accident. And similarly, for any person who is walking on the road for or crossing a road, and then signals, so we have this traffic signal, so we train this model, so the car will see that now the light is red, so I have to stop. So everything what you heard about this autonomous vehicles is based on this object detection. So we train our model and fit it into this car, and then this car goes on the road without a driver. And now comes the surveillance and security. So what happens now? Let's say you have your house, you have a garden, and now you know that because you live in that house, and you know that after 10 or 11 p.m. you don't go outside in the garden. So what you can do, you can deploy this model in your garden, and whenever a person enters in your garden, this model will detect that someone has entered your garden, and it will alert you that someone has come inside your garden without your permission. So you can use this as a surveillance and security. So this example is about your home, but you can deploy it in some sensitive area where people are not allowed to enter. So you don't need to put a watchman there that go and sit there and see if a person is coming inside or not. So here, instead of that, you can deploy this model there, and if anyone tries to enter in the prohibited area, that person will be detected by this surveillance and security. So this is one of the implementation that you can apply in your security. Then the next one is medical imaging. So there are various medical diseases that we cannot see from our eyes. So they are very, small in structure. So in that case, we can use this object detection technique. So we can train our model on all those medical issues, and then we can use this model to detect whether, for example, a person has a tumor or not. So in medical field also, it is very helpful. You can deploy this model and you can diagnose your patients. And then we have this last one here. So this is industrial automation. So you must have seen or must have heard about these robots in the restaurant nowadays. They are serving as a waiter. If you order them, they will bring you some food or breakfast, whatever you order them. So this is also based on object detection, where you train your robots with your images, with your voice and text, and then based on that, these robots will behave and they will respond to you. So these are some of the areas where you can apply object detection, and these are some of the major or the most important areas. But there are many other areas as well where you can apply this object detection. This is a very useful technique, and nowadays people are using it for attendance purpose in offices. If you go to the airport, they are using it to do your identity verification. So they will match your live photo with your ID card, and if it is a match, then it will automatically allow you to enter inside the airport. You don't have to do the physical identity verification. So there also it helps a lot. So these are some of the areas where you can apply object detection, and it is very helpful. Now let's come to the methods. So we have seen that we can apply this object detection in different areas, but how to apply them, and can we use a same model in all the industry? Is it possible to use one model that will fit all the use cases? So no, there are different models for object detection, and it will depend on your use case, what use case you are working on, and what algorithm is giving you a good results based on your own use case. So if you see here, these are the different algorithms that you can use for object detection, and they are not ordered. So I mean, these are not ordered like this is the best one or this is the worst one. These are all put randomly, and each of them are really good, and you can try and apply them on your data set, and you can see which one is working well for you. And if you want to know more about these algorithms, then definitely you can go on their website and read about their documentation. And we are going to use one of the algorithm from here. So if I give you a very rough idea about these different algorithms that you can use to apply on your use case. So the first one is RCNN. So it is based on convolutional neural network. And if you know about this convolutional neural network, then it will be easier for you to apply this algorithm set, because it will be using most of the things from your CNN, and then some from the then some of its own function. Then the so we have this RCNN, and then we have fast RCNN. It is nothing but the advanced version of this RCNN. So what happens every year, or every time we see an improvement in the algorithm, or we see a new algorithm is coming in the market that we can use for the similar use case, or for the similar problems. So fast RCNN is nothing but an advanced version of RCNN, and this also includes a convolutional neural network. And then you have something here, pooling, ROI pooling, which is the additional that you will get from your previous RCNN. Then we have another advanced version of this fast RCNN, which is faster RCNN. So these are nothing but the advanced version of these two algorithms. So this was the first, then this is second, and this one is the third. So if you and I would always recommend you to start with the basic, never go with the high level algorithm. Because there are multiple reasons. The first one is it will be very harder for you to understand. The second one is to understand that algorithm, which is the advanced version, you need to know the previous version of that algorithm. So if you don't have your basics clear, then you won't be able to apply the advanced version. So always try with the basic one, try to understand it, try to understand how it works. And once you are well aware of that algorithm, you apply it, you see your results are not really good or you need improvement, then go to the next steps. Then you will know what is the difference between your previous one and the advanced version, and whether this advanced version will really help you or not. So this is how you have to choose algorithm. Never go with the latest or advanced one just because you want to get a good result. First, try to understand how these algorithms work, why we have this advanced version, what were the flaws with the previous version that they have introduced this the advanced version. So this should be your approach when you are learning this, when you are learning any algorithm, not just about this object detection, but any algorithm in general. So always go with the basic one, implement it, check the results, and then go to the next steps. Now we have this SHD. So this is single shot multi-box detector, and it is different from these algorithms because it doesn't involve this CNN architecture, that is the convolutional neural network, and it will have some bounding boxes. So that I have shown you in one of the picture, those red triangle or the different triangle that we see. So those are the bounding boxes, and you must remember this word bounding boxes because throughout this computer vision, throughout this object detection, you will come across bounding boxes. They are very, very important because we first create a bounding box on any object, whether it is an animal, a person, a car, or anything. So bounding box is very important. You must remember them. Then the next one is YOLO. So you only look once. This is really a good algorithm that you must try if you are experimenting and if you are beginner and if you want to learn more. This is really interesting, and they are always coming with some advanced versions. So there are different versions of YOLO, and you will also get a lot of tutorials on for YOLO on YouTube or anywhere. So this is really good one, and you must try it, I would say. Then we have this Retina Net, and so this is used when let's say you have your data set and there is a class imbalance. Now you must be wondering what is class imbalance. So let's say you have two classes. You have a class of dog and you have a class of cat, and there are total 1000 pictures of both dog and cat. But out of 1000, you see that you have only 100 picture of dogs and 900 pictures of cats. So that is class imbalance because there is a lot of, or there is a 90% picture of cat and only 100 picture of dog. So when you train such model, you will see that your results are not good because your model is dominated by the picture of cat. So this is imbalanced. And here you can use this retina net algorithm. This algorithm will help you if you have a class imbalance. Then you have efficient debt model, and this will just optimize your accuracy, and also it will do the scaling. Then it also has feature like feature network, so you can also use this one. Then you have CenterNet that you will see here. So this will predict objects, object centers. So it will predict the object centers, and regardless of the bounding boxes, that means even if your bounding boxes are not there or if they are not placed well, it will be able to predict these objects centers. So if you see that you do not have bounding boxes or you find some problem with that, then you can use this center net algorithm. Then we have this mask or CNN. So it is also an advanced version of this CRN you will see here. So what it does here is it will create a mask of an object. So for example, let's say you have an image of a cat. So first, what it will do, it will not create a bounding box and then just try to detect the object. It will create a mask of that cat and another image, and that image will just have mask. So what do you mean by mask? So let's say you are standing under the sun and you see your shadow. So your shadow is nothing but your mask. So it creates a mask using this mask RCIN. It will create a mask of your object, and then it will do the object detection or classification. And then we have this cascade RCNN. So it will improve your detection, and it involves cascades, and it is a good algorithm for object detection, and we can definitely use it. So these are the different algorithms that you can use to detect objects. And now let's talk about OpenCV. So we have seen that what is computer vision, what is object detection, what are the different ways to, or what are the different algorithms that we can use to detect these objects. Now we will learn about OpenCV. So OpenCV, what is OpenCV? It is a computer vision library. What we learned that computer vision is nothing but if you are working on image or video data, you want to analyze them, you want to make a model out of them, then you have to use computer vision. Now, for computer vision, what are the different libraries that we can use to do this computer vision things? So we have this OpenCV as one of the library. And you must have heard about TensorFlow, PyTorch. So we can use all those libraries as well. But OpenCV is a really good one, and it focuses entirely in computer vision, and it has a lot of advanced algorithms, and it has a good community support. It is an open source computer vision and machine learning library. So it was developed by Intel, and you must have heard about Intel because we all use our processor and they come from Intel. So it was developed by this Intel, and now it is maintained by the OpenCV community, and it's an open source library, and it will provide you a wide range of tools and functions that helps you in your computer vision applications. And you will see a lot of documentation, a lot of tutorials online that you can go through and learn about this OpenCV. And as I have said that I also have a playlist on my YouTube channel about OpenCV where I have around, I guess, 25 videos. So you can also watch them. And now let's go to the next slide. So what is the overview of OpenCV? So where we can use this library. So we can use this library in image processing. So if we have our image data and we want to process that image, and now what do we mean by image processing here? So let's say that you have image of cats, dogs, or humans. So as you know that machine learning model or your neural networks, they do not understand anything except numbers. Even in our computer, what we type, so we write in our notepad, we write in text, but when it goes to our computer in the backend, it has some, binary numbers. So our computers, they don't understand anything, text or images or videos. Similarly, even our machine learning algorithms or deep learning algorithms, they also do not understand images or videos. So whenever you have images or videos, you have to do the pre-processing. That is, you have to convert those images or videos into numbers before you pass them to your machine learning or your neural network models. So image processing can be used. So OpenCV can be used for image processing. You can convert your images into numbers and then you can pass them into your model for your classification or object detection, and so on. Then we have this feature detection and matching. So what are features? So we have our image and we want to get the features. So let's say we have an image of a dog. So a dog's ears, nose, eyes, lips, legs, they are all features. They are all the features of a dog, and that is feature detection. So we will detect these features, and based on these features only, we will be able to classify that okay, this object is a dog. Because how you would be able to classify whether this is a cat or this is a dog? You must have something unique about these animals. So to get uniqueness, you need to know the features, and features are nothing but let's say you have this a dog's four legs, then his ears, his eyes, his shape, his hair, his height, everything. These are all the features of a dog, and that distinguish it between cats. So you have a cats are small in size. So those are the features of cat. They will have small in size, their colors, their hair will be different, their tail will be small, dog's tail will be larger. So these are the feature detection. And matching is nothing but when you match a picture. So you have, let's say, image of a dog, and you have one image which has just ear, and now you try to match the ear image with that complete image of a dog, and you find that this is a match. This ear belongs to that dog only, so that is feature matching. And then we have object recognition that we are going to see in this video. Then camera calibration. So you can, so if you have some images and they are not correct in shape, then there also you can use this OpenCV and correct your images, or you can remove the distortions from your images. So there also you can use it. Then you have this 3D reconstruction. You can also use OpenCV for your 3D images, and that is also very helpful. Now, what are the steps in object detection? So let's say now you have image, you want to do the object detection. So you must know what are the steps you need to follow to achieve this. So the first step is data collection. Now, let's say I want to do object detection. The first thing I have to do is I have to gather all the data. So first is you have to gather all the data. Now, if you're doing for images, then gather for images. If you are working on videos, then gather for videos. So you must have a good amount of data, not just a handful of data like 10 or 15 images, but a good amount of data, 100, 200, 500, 1000, as much as possible, but not less. Then the second one is data annotation, label. So now, as I said that you have an image where you have this. In one image, you have like cat, you have dog, you have duck that we have seen in one of our previous slides. Now, how our OpenCV will detect whether this image is of dog, this is cat, or this is a duck. So when you train your model, in that training model, you have to label each and every category. So you will label that cat as cat, dog as dog, duck as duck. Now you will do, let's say you have 1000 images, and you are going to train your model on 70% of your data. So out of 100, you will label 70 images. That means in 70 of the images, you will write that this is of cat, this is of dog, this is of duck. And the 30 images that will be used for testing. So once you do the label, you will train your model, and now you will pass these 30 images which are without labels, and now your model will detect whether this is a cat, this is a dog, or this is a duck. So that is labeling of your image. So that is very important, and this is how you will find the object or the correct object in your image. Then is model selection. So you have done this on 1000. So on 100 out of 100, you have done the label on 70, and 30 you have used for training. Now you see that your model is giving you only 50% accuracy. So you see that no, this is not good. That means it is like a random. Sometimes, so out of, if you are uh, selecting your 50 images, so now 50, so if you are selecting, for example, 100 images, so 50 times it will say this is dog, 50th time it will predict this is cat. That means 50 times it is right and 50 times it is wrong. So you see that no, this model is not good. So you will retrain your model, and this way you will make 3, 4, or 5 models, and now you will compare the accuracy. Okay, my first model gave me 50%, second gave me 60, third 65, fourth I got again 60, and fifth one I got 67. So now you have 5 models, and you see that the highest accuracy is given by a model whose accuracy is 67%. So you will select that model, and that is model selection. So you will choose a model which has the highest accuracy, so that when you again do the prediction on your unseen or new data set, you will get a high accuracy. So that is model selection. Then we have model training here. So what I have initially told you is model training and then model selection. So this model training part will actually come before this model selection, and this will go here. So my mistake. I have to put this here on the right side and this is on the left side. So first your comes will model training and then will comes the model selection. So now you have selected that you have got a model whose accuracy is 60%, 67% as compared to the other 5 models, and you have chosen this model, and now you will apply this model to do the object detection. And once you apply this model, you will get the results, and then you will get a bounding box, and on that bounding box you will see the category, this is cat, and you will also see how much percent this model is confident that this is a cat. So sometimes you will get 80%, sometimes 90%, sometimes 75%. So that is how you will do the object detection on your images on your testing data set. So these are the 5 steps of involved. The first one is gather data, get all the data of your images or videos, then label your data, that is important. Then do the model training, make 4 to 5 models, then compare the results, which model is giving you good results, select that model, that is model selection. And once you have done the model selection, then go for the object detection, apply this model there and get your results. Now, there are some of the object detection techniques in OpenCV. So what we have seen in our one of our previous slide. So I'll show you here. So this is in general. These are the different algorithms. So YOLO is a different one. RetinaNet is different. They are all different. So these are the different techniques or different libraries, I would say. These are the different libraries that you can use. And OpenCV is also one of the library in this. And now inside the OpenCV, these are the different algorithms that we can use for object detection. So the first one is Haar cascades, then we have template matching, then we have feature matching, and then we have contour detection. So if I talk about this Haar cascade, so what is the, it is based on the machine learning techniques, and it has rectangular features. And when we apply this algorithm, it uses ADA boost. So ADA boost, you must have heard about this boosting and boosting algorithms. So in that boosting algorithm, we have this ADA boost here. So it uses ADA boost, and we have this Haar cascade as a pre-trained model. So we don't have to write this algorithm. It is already pre-trained, and we can get it from the GitHub page of this Haar cascade, and we can use it from there. So what we will see, so now you see here image. So this is image of a person. So first, the blue color triangle you will see here, this is nothing but a bounding box, and this is detecting the face of this person or this woman. So this blue color is detecting face, and these red colors, these are detecting eyes. So this we are going to see in our Jupyter notebook, this Haar cascade algorithm. Then the second one is template matching. So what happens here in template matching? So you see the image of this Coca-Cola here. So this is the original image, or this is the complete image. You have complete Coca-Cola bottle here, and on this bottle you will see a sticker labeled as Coca-Cola. So this is a template. So what we do, we have just a template here of Coca-Cola, and now we want to match. We want to, so now here you are seeing that we are having only one Coca-Cola bottle, but in actual you will have a Pepsi, you will have Sprite, and various other soft drinks that are available in your country. So in our country, in we have different soft drinks. So maybe Pepsi is one of them that might be available in your country. Then there is some Sprite which is available in my country. So there will be like, let's say 10 to 12 soft drinks here, not just one image of Coca-Cola. So there will be 10 to 15 images of these soft drinks, and you will have just one template, and that template will have this Coca-Cola. And now you have to match this template against those 15 soft drinks. And if you are able to correctly match with this Coca-Cola bottle, then your model is doing good. So this is template matching that we can do with the help of OpenCV, where you will have 15 or 20 or any number of these soft drinks, and you have to match that template against the soft drink, and you have to find which is the correct one. So that is template matching. Then we have this feature matching. So now you see here, we have a desk here. On this desk, we have a book. Then we have this is a pot, and this is a bowl, and inside this pot we have this tree here. So what we are doing here is we are doing the feature matching. So we are taking this image as a whole. So we have this table, book, pot, ball, and this grass here. And now we have just an image of book. Now we want to match the title of this book, the image of this book, and here is also there is some subtitle here. So we want to match this feature with the book. Now it is difficult because here we are not just having book, but we are having a lot of things. But it is able to correctly detect that these images or these titles, they belong to this book only. They are not saying that this image is belonging to this ball, or this is belonging to this pot. And not just this table, but you can have a lot of things, and not just one book. You can have a lot of other books. For example, you will have a book here, let's say OpenCV with Python. Then you have another book, programming, learn how to program, and so many. So out of all the books, it should be able to detect this book and its features, like its name and image, from the original ones. So that is feature matching. Then we have contour detection. So contour detection is nothing but detecting the edges. So you have this image on the right hand side. You will see that this is a image of a person hands, and what it does, it will detect the boundary or the edges of your fingers and your hands. So that is nothing but contour detection. So for that, first you need to convert your image into grayscale or black and white scale, black and white in color, and then you have to apply this contour detection, and you will get your results. So these, what you see here, this, so we have this algorithms here: feature template matching, feature matching, contour detection. So these algorithms, you can find the video on my YouTube channel to learn more about this. They are in detail there. So you will see how you can apply this and how you can find it. And now let's talk about this Har cascade algorithm that we are going to see in our Jupyter notebook in few minutes. So how does it works? So it is one of the oldest machine learning algorithms that we can use in computer vision to detect the face or eyes or even smile or even a vehicle in an image. So how the training works? So we have this pre-trained model that we can download it from their GitHub page. It is open source. And what how it works is, in this we have so what it does, let's say we are passing a image here, an image of a person. So it will create two pictures. One is negative and the one is positive. In negative, we will have a different picture that is not similar to our image. And in the positive one, we will have the picture of our image itself. And then it will create a box, and then it will uh, move that box over the image, and it will try to detect the features. And once it detects the feature, then it will be able to identify the face of a person, the eyes of a person. So that is Haar cascade algorithms, and it uses this ADA boost. So this is nothing but a boosting algorithms, and the full form of this is nothing but adaptive boosting. So you can use this to select a subset of features that are most effective or that are helpful in distinction between the positive and negative samples. As I've said that negative samples are images that is completely different, and positive images are samples that is our actual image samples. And then in this algorithm we will have some weak classifiers. So AdaBoost will make those, combine all those weak classifier and make them a strong classifier, and then do the prediction. And so this is the sample photo. Here you will see that so there are different stages in Haar cascade algorithm, and it will try to start from the first one. So when it has only one feature, so it will say that, yeah, this could be a face. It is not sure because now it has only one feature. As I said that if you want to find out that something is really an image of a person or image of a let's say a dog or cat, then you must know more detail about that image, like here. Then we have like height and the face and everything. So those are nothing but features. So it will start with that, and first with just one feature it will not be sure, but it will say, yeah, it could be a face. Then it will get more features, then also it will say, yeah, it could be a face. And as the number of feature increases, then it finally says that with confidence that, yeah, this is a face, and this will detect, okay, this is a face, and I am very confident about it. So this is how this algorithm will work. Now we will go to the Jupyter notebook, and we will see in code how we can find the find this face and eyes in our image. And before that, I will just give the credit to the pictures that I'm going to use in the Jupyter notebooks. So these two pictures are from this Instagram account, and this she also works on machine learning, and she has some good videos on her Instagram about this OpenCV. And then I have also used one picture from her accounts. She's also into programming. So now let's go to the Jupyter notebook, and we will see in code. Yeah, so this is the code here. And the first thing that you need to do is you have to import these libraries. The first one is OpenCV. So you have to import this OpenCV. Then you have to import NumPy as NP. Then you have to use import matplotlib, and this is used for displaying your images. Then you can check the version of your OpenCV, what is the version. So this I printed because some of you might find it that you are not able to detect it or any other problem. So you can check whether you are having the same version. At least you should have this 4.6. And then this is the code. So for face, eye, and smile, so these are the pre-trained models models that you can find on their GitHub. So what you have to do when you install this OpenCV, it will come with your OpenCV, and you have to find the location where these files are present. So for example, in my case, I have found that these pre-trained models are present here in the C users, Amir, Anaconda 3 packages, library OpenCV 4.7, and so on. And so here it is available. So if I show you this folder here, so this is the folder where I can find these pre-trained models here. So you have to pass the location of these folders. And then first is you have to load your image. So you have to give the image name, and you have to write the proper extension, whether it is JPG, it is JPG or your different kind of extension. And then you have to give the path of your image. I hope my screen is visible. And then the first thing that you have to do is you have to detect face in an image. So you will use this face cascade pre-trained algorithm. And in that, you can pass your image. You will convert your image from your original into a grayscale image. And then you will pass these hyperparameters such as scale factor, minimum neighbors. And these are the default parameters that I'm using here. So if you see that your results are going wrong, then you have to play around with these parameters, and you have to check whether you are getting whether your images are being correctly identified or not. And then you have to create a loop here. And so this loop is nothing but when you are detecting a face, you have to create a rectangle. So for creating a rectangle, you will write this loop here. And in this loop, what you are passing here is nothing but these are the height and weight in that image. And these numbers are nothing but color. So this is the color channel. So this is R, G, and B. So R is 255. So that means you will see the bounding box in red color, and this is G and B, that is green and blue are 0. So you won't see green and blue, green and blue color here. So this 255 means your bounding box will appear in red color, and this is nothing but the area of interest in your picture. So you have image, and because in the entire image we are just focusing on the face, so that is why this is our area of interest. This is the only area where we are interested in, where we want to detect the face. That is why we are defining here the area of interest. So if I execute this code, you will see that we will have this image here, and in this image you will see it has detected our face. And now the bounding box color is blue in color. Also it is in blue in color because in OpenCV the color channel is BGR, and in Matplotlib the color channel is RGB. BGR means your first color will be blue, and that is why when I put here blue color, that is 255 here. So I see this bounding box in blue in color. So let's say if I want to change it, I'll just close this image. I'll make this as 0. So this is blue, this is green, and this is red. Now I will make this 255, and this time our bounding box should be in red color. So now you can see I have executed the code, and now this bounding box color is red in color. And to close this image, I will just press any button here, and this image will be closed. And that is because I have written this function here destroy all windows. So uh, if you press any button, it will close your image. So this parameter is about the color of your bounding box. This is about the height and width in faces, and this is the area of your interest. So let's say if I execute this code again, now you see that I'm able to detect this face correctly. But if in some cases you will see that your rectangle is actually detecting something else, maybe your hair or somewhere here. So in that case, you will have to adjust this area, that is your region of interest. You will have to adjust it, and in that case, this will come in play. So you will have to adjust this. You might have to increase these values, and you have to check whether now you are getting a good bounding box on your face or not. Now, so in this image, we have just detected the face. Now we also want to detect eyes. So let's say I am creating this one more function here. So here I am detecting face, as well as here you will see I am detecting eyes as well. So this is eye underscore cascade. And here also I'm passing the default parameter. Minimum neighbors is 3 and minimum size is 25, 20 by 20. This is nothing but the image size. And this is a minimum neighbors is how many neighbors close to the image that we are looking for. So this is 3. And then we can uh, create one lambda function to make sure that we do not pass just one complete rectangle over both the image, but we are actually passing two different rectangles on two different images. So so this function is for that one, and then we will loop over the eyes. So in this one, we have only this code is important because we are first detecting face and then detecting the eyes. And this smile one we will see in the next image. So if I execute this code here, so here you will see in the output. Now we have not just detected the face. So this is the face that we have detected, but we have also detected these two eyes as well, and they are detected properly. So our algorithm has performed really well. It has able to detect the entire face as well as these two eyes. Now I'll just close this image. Now in the last one, I will show how we can also detect smile as well. And for that one, we will use this smile cascade pre-trained model. And whatever you see here is coming from these three lines. This is for face, this is for eyes, and this is for smile. And these are all provided by Har Cascade that will come with OpenCV when you install your OpenCV on your machine. This will come with that. You will just have to provide the location. So this is very important. Once you provide the location, you can start using it. You don't have to do anything. You just have to modify your code if your code is not able to detect the eyes, face, and the smile correctly. So now let's execute our last image here. So now in this image, you will see we have detected face in blue color, eyes in this green color, and then smile in this red color. But now you will see we are also having these two bounding boxes blue in color. So they are actually wrong. That means we need to fix this, and we need to tune our parameter. So for that, we will have to play around with these parameters that we have passed here. Maybe we have to change the height, or maybe we have to change these values. So that is something we need to do it to adjust it and to make it proper. And I give you this as a practice test so that you can play around with this parameter and you can fix it. You just have to remove these two bounding boxes. Otherwise, image is perfect. You have a face, you have eyes, and you have smile detected. So this was the last image, and this is how you can do object detection using OpenCV. So I hope you found it helpful and useful. And now we'll start with the Q&A. If you have anything, please feel free to ask me. Yes, so this works in real time for videos as well. And you will see a lot of good tutorial on videos where you will see cars are running on the street. You will see bounding boxes. And on that, you will also see the accuracy that this is a car with 80 or 90% accuracy. So yes, this works in real time as well, and for both videos and audios. And you will find a lot of great tutorials on YouTube. So I would suggest you to use about vehicles, how you can find vehicles in the images. That is going to be one thing. The other would be about detecting animals, then detecting, let's say if you are on the street, about traffic signal lights, then pedestrian walking on the street. These are some of the very interesting things that you can try. So on gesture recognition, no, it is not limited to hands, but your smile or your handshake. And if you are bringing some bottle or anything in your hand, so it will also detect that. And it has improved a lot. So you will really find some more things that you can add in gesture recognition. If you have anything, please feel free to ask. Yeah, so for OpenAI, you have there are some things that you can really use here, and that you will find it on cloud. So on AWS, for example, you will see that you have different libraries or different modules. In even in GCP, there are some great libraries that you can use. There, you don't have to do anything, not even processing. You just have to upload your images, and it will do all the things for you. So in AWS, what I know is there is one image recognition algorithm And then in GCP, we have some Vertex AI. Mm, then there are other algorithms, AutoML. So yes, there are OpenAI where, especially on the cloud, where you don't have to do anything. Everything is done by the cloud itself. Yeah, so scale factor is uh, about scaling of your image. So we have different height and width and length. They are all in different sizes. For example, if we go on a scale for height, so we have somewhere between 0 to let's say 200, and then for weight you will have a different scale. So there are different scales in our image or in our video, and to bring everything on the same level, so with this we scale these images so that everything comes in the same level and they are all having their equal weights, not they are not dominated by their features. For learning OpenCV, so I would say I do not um, know about the best book, but yes, whatever I have shown you here, you can find it on their official website. They have a great documentation. You can just go through your documentation and you can apply in your own examples, and you will really get good results. And apart from that, you can, yeah, so there is one very a good course on Udemy on OpenCV. I just don't remember the name now, but that's a really good course that is from beginner to the advanced level, and there you will get one project about the video as well. So I have seen that tutorial. I have seen that course, and that is really good. I don't know the name now, but yeah, that is a good one. Maybe you can message me on LinkedIn, and I can find that Udemy course link and share it with you. If anyone has any other question, please feel free to ask. Okay, how many samples do we need for good database? So you should have at least more than 200 or 300 samples. That would be great. And it also depends. For example, if you have just 70 images, and so to make a good models, you need to do the training on 70% of your data. So out of your 100, 70 will go for training itself, and you have only 30 for testing. So 70 might not give you a good result, because when these 30 other images are coming and they have some features which are different from the 70 that you have provided, so the model will not be able to correctly identify or classify it. So to make sure that your model has detected all the features from your training data, always make sure you have good amount of samples. So I would say 300, 400, 500, but never go with 100 or 200. They are quite less. Okay, if we are done, then if you don't have any question, thank you so much for liking it. I really enjoyed it, and I'm very happy that you all have liked it and you all have stayed till the end. That makes me really happy. And also greetings to you from India. So if we don't have any more questions, then I wish everyone have a good day, and thank you so much, Data Science Conference, again for giving me this opportunity.